Welcome everyone to our session for Working Group Component Standard. My name is Mike Taufen. This is my co-presenter, Alex Knipping. Today we'll be presenting on some of the technical challenges that Alex encountered while trying to implement various pieces of ComponentConfig. So just quickly before we get started, a little bit about the working group. We formed this working group a couple years ago with the idea of trying to develop a standard foundation for core Kubernetes components to build on top of. We have many core components such as the API server, the scheduler, the Gcublet, kube proxy, and many common functionalities that are distributed across these components. But we didn't necessarily have standard implementations of these functions across the project. And so that's the idea behind the working group, is to provide a place where we can talk about and design and standardize these solutions. So these are a few examples, how components are configured, how they sort of report their status, various integration points, and sort of logging and metrics are the main areas. So I'm going to turn it over to Alex and let him talk about sort of how he was introduced to the working group and some of the projects that he's worked on.
Thanks, Mike. Yeah, before we get started, just a quick overview of the agenda today. So we already heard the introduction from Mike. I'll be talking about points 2 and 3, basically two of the problems I encountered or I dealt with when working with the working group. And then we'll close up with some shout outs of what works we're doing and of course Q&A. All right, so this is me. My name's Alex. I'm a site reliability engineer at Exering in Munich. We're building a German IPTV platform. And it was around mid-May or like mid last year that I got interested in contributing to the Kubernetes project. I think it was for KubeCon in Europe around May when I went to a couple talks and I saw a couple of working groups or special interest groups present themselves. I think one of them was C Cluster Lifecycle, and it was really a nice and open environment and a very welcoming community. And it was around that time where I was trying to get into the project. I tried to contribute a little bit. I started with some GoLint issues, although that got a bit boring after a while. So I was kind of looking for a new challenge, but it was a bit daunting. Like Kubernetes being such a big project, it can be quite tough, or at least at the beginning, to really get a grip on this if you want to start out contributing. So the guys from C Cluster Lifecycle, they pointed me actually to the working group, and I didn't have any prior experience to that. I've had little Go experience, certainly no open source experience, and he just told me just talk to them, talk to Mike and Lee at the time, and I went there at a good time. Basically, they just had a contributor onboarding coming up. And we discussed a couple of things. They're really, really nice and welcoming. Didn't really matter that I didn't have any prior experience. There are a lot of issues actually in the community that can be tackled by people with a bit fewer technical skills. But they walked me through the code base regardless. And we talked a little bit about the projects I could be working on. Why am I telling you this? Well, I want to structure this talk a little bit like this to take you on a journey. It's like my journey through the project, or at least over the past year, and just really show you what kind of problems I dealt with and how I learned step by step. And hopefully, if you're looking to contribute or if you're thinking about it, but you're also a little bit scared as I was, maybe I can take away some of that and show you, it's really not that of an issue, and there are loads of friendly people who can help you with it. All right, so back when I started coming to the meetings of the working group, there was just this PR was just merged, basically Codec Factory options, which allowed some options to pass to Codec Factory, mainly the pretty encoders and the strict decoders. What those are, we'll explain in detail, but basically the problem was that when you load a component config, which is a YAML file, which configures a component like the API server or Gcublet, those YAML files can be malformed. So they can have duplicate fields or typos in field names in the YAML, and those errors would be ignored, right? And this could lead to undefined behavior. So we can't really assume like which of those fields are intended or not. And back then, that wasn't really happening like anything straightforward. I think it was just like the first field encountered it took, but as I said, it could lead to unexpected behaviors. And with this PR merged, basically it was creating the prerequisite to deal with this problem, to actually load the config file and arrow out on those, like malformed fields. So this was like the first challenge the guys suggested to me. It's like, no, why don't you deal with this? It's a good point to get familiar with the code base and learn a bit about API machinery. So this is what I did. This is what I told him I will tackle on. So it sounds quite straightforward. We have malformed YAML files, and if we load them, it should throw an error, right? So it sounds quite easy, right? Well, at that time, I didn't really know anything. What was a component config? Well, obviously it was the YAML file. You pass to the component, but how does it work? Like, what are the concepts behind it? Also, what's a codec? What's the Codec Factory? I didn't really have any clue. So, let's start at the beginning and walk a little bit through the process. All right. So this is the configuration. It's called Gcublet configuration, and this is a component config, and it's for the Gcublet, right? And if you installed a cluster before, if you did Kelsey Hightower's Kubernetes the hard way, you've probably seen this before, created it yourself. This config file you pass to the Gcublet, as I said, when you started. Now, this goes alongside to right now the CLI flags as well. Now the CLI flags configure the Gcublet too, but like in the future, we want to like phase out the CLI flags completely. Why is that? Well, there are loads of problems with flags. One of the bigger ones is that you can't version them, right? It's really tough to deprecate flags in a way that it doesn't break, older clusters or things like that. So this is just one of the problems. I won't go into detail here. If you're interested in that, and there's still lots of work around this section, like deprecating CLI flags, I recommend you to talk from the working group last year at KubeCon San Diego, I think, and there was some great detail into that. So this all happens on a node, right? All right. So, and this is the problem basically we're trying to solve. So if you have, a config here, and you have a duplicate field, like one's cluster local, the other one's my cluster local, like which of those fields, do you actually, want to load? It's not really clear. And the same as this area is this like a field which doesn't really exist in the V1 Beta 1 API. So what do you do with it, right? And as I said, the idea is to load these configs. And if, through the process of loading it, if you encounter any of these errors, like you error out. All right, so the first thing I did, basically, I loaded up the editor, jumped right into the code, and digged a little bit through the Gcublet code base. And basically, I found this function, right? UFS loader. It takes a file system and a Gcublet file as a string. So the file system is just an abstraction, basically, for testing. Whereas the Gcublet file is the path to the actual Gcublet YAML. And what does it do? The first line here in 148, it returns a Gcublet scheme, or like basically a new scheme in Codex, like here, right? Didn't really know what that was, so follow the function. And in scheme.go, you see it returns a scheme and a Codec Factory and an arrow. So there are a couple of points here, which, obviously I didn't know exactly what they were. So we have a scheme which gets returned from the runtime package. Then some things are added to the scheme. And then we take the scheme and then return some codecs, right? So obviously the question were here, like what's a scheme, and what's added. And looking up, like digging into these questions really led me down the API machinery rabbit hole. I won't go into too much detail here. I'll just try to give you the overview. But these are like core Kubernetes concepts. It's really good to know about them, especially when you want to start out. So let's start with the scheme, right? let's say you're like kube control and you fire up a get pods and it's like, you know, asks the API server and the API server responds like, here's some structs, you know, here you go. Now, how does kube control figure out if those were actually pods which were sent over here, right? These are just like, for all intents and purposes, just, you know, some Go structs it received. And this job actually from translating it from like, you know, some struct to a known type, this is what the scheme does. One of the things it does actually, as I said, like the scheme is one of the core concepts in Kubernetes and a bit of a like a Swiss Army knife for API machinery. But one thing it does, it provides a mapping between an object, so like a Go struct of a pod, for example, to a specific Go type, which is called group version kind, or GVK in short. And you'll find this a lot around the code base, this terminology. Now, in order for it to do it, you know, we need to tell the scheme what kind of Go types it knows. Basically, we have to tell it, you know, okay, here, this is what a pod looks like with version v1. And as soon as we have registered that into that, we can pass it an object and we will turn as the group version kind if it knows about it. So it's really an elemental process which happens all the time, this kind of conversion. And if you go and dig through the code base a little bit and look up the scheme, you'll find, you know, a comment that says it's the foundation of a versioned API and configuration over time. And as you might know, you know, every API in Kubernetes is versioned, or like pretty much everything is versioned. And the scheme basically provides us the tools to, you know, like work with these versions, to convert between them, and to do, yeah, conversions basically. And this can easily happen, you know, if, for example, the client is has a different version than the API server. Like I think with the version skew policy, we allow like 2 major versions to differ, if I remember correctly. So, you know, we definitely need to have some tools to convert between these different versions. All right, so this is what the scheme does, you know, it gives us some tools to convert between versions. And speaking of versions, this is exactly what we do here. You know, we tell the scheme which versions are available. And we can see here it's the v1 beta 1. It's the one we, you know, it's the version we see here. So v1 beta 1. This is basically the external API, it's called. And then we also register another thing in here, and it's just called kube-config without a version. Now, this is what is called the internal API. And this was very confusing to me at the beginning, like internal and external versions. You know, what does it mean? Like, why do we need this? And it's basically like the internal version is like a hub type, right? And it's used to convert between any different versions. You can obviously convert between an external version and the internal version, but you can also convert between 2 external versions going through this hub type called the internal versions. So let's say v1 alpha 1 has, you know, fields A and B, and v1 beta 1 has fields B, C, and D. The internal version would know about all fields A to D. So, and it would provide you with some tools to, you know, convert between those versions, do some defaults, all kinds of things, you know. So in the end, you know, you don't lose any information when you do these conversions. All right, so we have a scheme, you know, we register some versions into it, and then we pass it to a Codec Factory. We get some codecs back. All right, what's a Codec Factory? Let's have a look. Now, if you look through the code, you see that for Codec Factory, it says it provides methods for retrieving codecs and serializers for specific versions and content type. Now, you can see here in the Codec Factory, it has a scheme, it has serializers, and it has a decoder, a universal decoder. Now, there are a lot of things to it, but on a high level, basically a serializer or deserializing, what we do in our case, is we convert it from a wire format, so a YAML file, into a memory representation, which is a Go struct. Then we take the decoder and take the Go struct and map it to an internal or any external version, doesn't really matter. And basically this is where the actual conversion happens between the actual versions, yeah. And if we look down here, we can see it also has some options. Right, so in this case, we have strict and we have pretty, and strict is what we want. right? So configures all serializers in strict mode. And this is exactly the behavior we need in this case. So if the serializer encounters any errors or like any unknown fields, doesn't know about, will throw an error. All right, so we have everything covered. We have the scheme. We have some versions which we need, the internal version and the external version, v1 beta 1 in this case. And we have the codex, which we can use to actually convert and load the file. All right, so the idea is just pass the strict option here, behind the scheme, and it should be fine, right? Well, technically yes, it's just how it works. But there's one more thing we forgot, and I forgot this at first as well. So I implemented this, PR got merged, but then we got some ideas that we actually might break some clusters, some older clusters. How does it work? What happens? So let's say we introduce this change for let's say 119 is the current version. Let's say we introduce this for 119. But the thing is, when 119 gets released, this doesn't actually increase this version here. So the version of the API of the Qubit configuration doesn't go in lockstep with the Kubernetes release cycle. So what would happen? People would upgrade. Let's say someone has this config here and has a duplicate field. The change would get into the tree, and the user would upgrade his kubelet. And what would happen? The kubelet would fail, which would break the cluster in the worst case. And this is not something I as a user would expect, right? So because this version didn't change, why is my cluster not working, basically? This version kind of, especially like beta and upwards, implies some kind of stability in this case. So, we don't want to break any user clusters. So we need to figure out a way to, only strengthen this when this version changes. And this is exactly what we did. We strengthened the validation on the version boundary. And basically for v1 beta 1, we want to decode with some warnings. But on v1 beta 2 and upwards, we want to have the expected behavior that it will throw an error when the YAML is malformed. And what we introduced here is called the new lenient scheme and codex. It's like a helper function. And this is used to return a Codec Factory with disabled strict, so like the strict serializer is disabled, just for a single version. And this gets called with the scheme of the version for v1 beta 1. And just for this version, it returns like some codecs which have strict disabled, and everyone upwards, every version upwards will have the strict serializers enabled. All right, and we basically did this for every component. So for like the kube proxy, the kube scheduler, and Gcublet, as you see here, the first list, we implemented these first. And then we came, upon the issue just talked about, and then afterwards we shipped basically the lenient paths as well, is what we call it. So, this was all in the same release cycle, and so the user didn't really, recognize any of the issues, unless they were running from master. But yeah, so this only, like, all these changes got into the next version. I think it was 117 or 118. I'm not sure anymore. All right, yeah, so we did this for these components. Now, as you can see here, the kube-controller-manager is strike through, right? So actually, and I didn't know this before. So the kube-controller-manager doesn't use a ComponentConfig. I think it's one of the only components which doesn't. Why is that? This is what I asked myself. Why doesn't the controller manager use a ComponentConfig? And I asked it to the guys, and they told me, well, that's difficult. The kube controller manager works a little bit different than the other components in the Kubernetes cluster or ecosystem. And let's do it as we did earlier. So let's start from the beginning. First of all, what's a controller manager? And this is from the official documentation. Basically, the controller manager embeds core control loops shipped with Kubernetes. And a control loop watches the shared state of a cluster through the API server and makes changes attempting to move the current state towards the desired state, right? So basically it looks at like to the API server and it checks, is my cluster in the state it should be, right? If someone starts a deployment and the pod isn't rolled out on any node yet, there would actually be a controller making sure that would happen, right? And it's like this basically infinite loop, just always checking if a certain condition is true or conditions, and if not, it will try to reconcile that. So this is a controller, and the controller manager is a binary host. Basically, it is also like a hub or a host which holds all the controllers, basically, or almost every controller, and starts them, makes sure they're configured, and provides a home for them, more or less. Now the idea is that individual controllers are interchangeable. Users should be able to build their own controllers or build their own controller managers for in this regard. And so this is what we have to keep in mind. Well, probably not many are doing it, but it should be possible. It's one of the core principles of Kubernetes that you can exchange things and build your own stuff. All right. And if you look into the code, you can see what the controller manager does. One of the things it does, it has this function called controller initializers, and it has a map of basically the key of the name of the controller, and the value is a function which starts the controller. Right. So we have, I think, over 30 here, and this looks quite daunting. There's quite a bit of complexity in here. But in the end, that we're just starting individual controllers, and this can be configured from the command line. Of course, we don't have a ComponentConfig, and it takes a list. I think I'm not sure what the flag is called, but it takes a list, and you can turn on or turn off specific controllers. And by default, it has a star, so basically it turns on all the controllers, right? So the next question would be, okay, so it starts the controllers, but how are they configured, right? As I said, the controller manager deals also with the configuration of the controllers, or provides primitives for that. And basically, the controller manager configuration exists, and it's a version API, right? And it is a version API holding all the configuration necessary to start the controller manager and the individual controllers. Right. So in this case, it's what we call a container config. So we see here it has a type meta, which basically means it is versioned. It has like an external version. But then we have the individual controllers as fields in the struct, and each of these controllers basically holds each of these configurations holds the configuration for the individual controllers. Now we do have something curious here. It's called kube-cloud shared, and it holds configuration for shared related features both in controller manager and kube-controller-manager. So actually, the cloud controller manager used to be part of the controller manager, but it moved out of tree because it was just too much complexity, and the individual cloud controllers were differing, too much after a while. So, the maintainers decided to take it out of tree and maintain it as an individual controller, basically, which is not maintained by the controller manager. So this is the first, example you see of everything should be plug and play in a way. So, the controller manager doesn't really start or care anymore that much about the cloud controller manager, but there are still some configuration fields which are needed by both parties. Right. So this is why we have this configuration substruct, basically. All right. So as we said, the container type, the controller manager configuration is versioned. But if we look at the individual controllers, we can see that they are actually not versioned. They only have an internal API. And the first thing that gives that away is you look to the import paths. And if you see that these are coming from like in tree, so the Kubernetes /package basically directory, it's where the internal APIs are, like when you go to /config in the end. And this is what it looks like, right, conceptually. So we have one container type, and this is one version, but it loads all it embeds all the configurations of all controllers. So if anything changes here, it goes into the same version of this. So we basically version it more or less in lockstep, although these are all internal, right? These are not really externally versioned. And if we go into any controller or like specific controller configuration, we can see we don't see a type meta here, indicating this is just an internal API. All right. So actually, there's no real argument against not having a configuration or like component config, at least not technically. We can easily just create a YAML file, give it a like GVK, a kind, an API version, an API group, and then we just list all the fields. And now we can load this, and we get a config from that. So it's not really a problem technically, right? So if it's so easy, why don't we have it yet? That was my question basically. And well, it's difficult. It's not, it is a technical challenge still, but it's also an organizational challenge. So we need to think about a couple of things, So for example, what happens if a controller moves out of tree? So we saw this with the cloud controller. We had to introduce a shared configuration field. Now, if we have to do this for every controller which we move out, it gets a bit busy in the code base, and it's not really, a nice solution probably. And then again, what happens if controllers share config fields? Actually, I think I looked at it, there are about 10, so like a third, a little bit less of a third of the controllers we have in the controller manager actually share some configuration fields. So we need to deal with this. What if, if we have a single controller which we don't want to get start from the controller manager? How do we, build a component config around that? Or what does it mean for our YAML file? Then what happens if an owner of a controller, or like the group owning a specific controller, doesn't want to follow this versioning? They're kind of bound to it as soon as we load it from a file. Or what happens if user wants to implement their own controller manager? Now, how do they, can they write their own component config? Like, what kind of primitives do we provide for that? And these are all like kind of tough questions. It's very much an architectural problem, and also like a community, organizational problem, I would say. There's a lot of talk and brainstorming which has to go into that, and it's quite difficult. Now, one option would be, for example, to just give each controller its own external version. So we still have the same API group, maybe we can share. We still have a container type, which is version, but then we also have individual versions, for the controller, and they can move as quickly or as slowly as they want. This could work, but the problem is we have a lot of controllers. So if you think about having external APIs, maybe several external APIs for each controller, this can get quite messy. There's a lot of code, a lot of duplicate code probably, which has to be written. It just quickly blows up in proportion. So it is a possibility, but it comes with some serious trade-offs as well as everything basically. And it's just something we need to get a consensus around, if we want to do this. So actually, the community has been trying to figure out this problem, since I think 2018. It was first Stuart who tried to, merge a PR which introduced a config for the controller manager. This one got closed because it was missing a cap, Kubernetes enhancement proposal. So shortly afterwards, it was Lucas who started the discussion around the component config for the controller manager. Started with some brainstorming in the design document. I have it linked here if you're interested, by the way. Just download the slides. You can go to all the links. And there was the initial discussion around it. Unfortunately, it kind of got a little bit stale. There hasn't been much around this topic. Stuart tried again in 2019, failed to gain some consensus. I think it also, slipped under the radar of some people, this cap. Unfortunately, he in the end didn't have much time and had to deal with other projects. So basically this kind of got stale, a little bit abandoned as well. So, and yeah, and this basically shows, the problem one of the bigger problems of such a big community or like open source community. It's quite difficult to get these changes through. Now, if it's not like the most shiny feature, all the core main contributor and companies want, if it's like some cleanup, and some housekeeping you want to do, it can get really, really tough to get consensus on these things, especially if there's no one real, with no big contributor driving it. It can get really, really hard. Okay, so what's the plan? Well, I thought the current plan is let's pick up where Stuart left, and try to get the conversation going again. Take his cap, maybe extend it a little bit, and try to get everyone on the table. And you might think now, so okay, so what's the plan now? Like how should it end differently than what Stuart did? Honestly, I don't have a answer for that. I'm definitely not more qualified than Stuart was, but at least I think we have to try. This is really an important issue, and we just have to get the conversation going again. And I'll just try to stick with it, or like we as a community, let's say, we should try to really stick our heads together and try to come up with solutions to this problem. Yeah, so that's the current situation right now. Of course, always looking for some help, or we are always looking for some help on this. I just mentioned 2 issues we're working on. There are loads more, the working group could use help with. So if you're interested in any of that, I think it's a really good way to learn about the code base, to learn about some core concepts in Kubernetes and API machinery. Please don't hesitate to just join our Slack, or come to the working group meetings, and we'll be happy to onboard you and help you become a contributor. All right.
All right, thanks, Alex, for the presentation, and thanks for all of your work in the working group. As we wrap up here, I just wanted to quickly highlight a few things. So these are some of the other projects and areas of work in our working group. Some are being worked on actively, some are not. So we have a lot of component config stuff, as Alex talked about in the presentation. There's some work that overlaps with that around command building, as far as sort of dealing with flags and that migration to config. There's a bunch of work going on. Contributor whose handle is Sarathias is leading that around standardizing the logging subsystem in Kubernetes, and kind of redoing a lot of that. And finally, there's some potential work around standardizing component servers and some of the common endpoints like healthz and configz between them. So if folks are interested in that, please feel free to reach out to us. We'll have some information about that right at the end of the presentation. And then the next thing, if we go to the next slide, I just wanted to give a shout outs to all of the folks who have contributed in some form or another, maybe just a couple lines of code, maybe a major project, to working group projects, whether that's contributing to things in the core Kubernetes repo or in our component-based repo in the past year. So thank you to all of these folks. Really appreciate all of your hard work. And finally, this is how you can get involved with our working group. We have weekly meetings on Tuesdays at 8:30 a.m. Pacific time. There's also weekly office hours for folks who are working on things and have questions or need help. And that's the same Tuesday, but at 10 a.m. We have our mailing list, our Slack, and our GitHub label as well. So please feel free to reach out to us. The best way to reach us is typically on our Slack channels. Thank you.